Okay everyone, we want to start looking at the concept of upresing now. And what is upresing? Well, upresing is basically taking an existing sim which has got cache data, rerunning that sim so that we get more resolution in that sim. So it's up resolution of existing data, as opposed to starting from scratch with a new sim and adjusting the voxel size. It'll be clearer as we actually start getting some experimenting in, and you'll get more of a feeling for it. First of all, let me just show you what I've done. I've got these three containers. I haven't labelled them with splines, but we'll talk our way through it. This one I'm going to use as the default. This one I'm going to use as a higher res, and this one I'm going to up res. Basically, I've got temperature, which is going to, and buoyancy and density, and the temperature will give the density buoyancy, so we're going to something will rise. But in all cases, I've switched off the fire shader because I only want to look at the smoke shader, and I've got a light with hard shadows on it. The reason being that we're going to see the detail more in smoke and density than we would in fire. And each one of these containers has a different cache. Okay. So we can keep them separate. Oh, they should have a different cache. That one, that one, that one. Let's put that on that one. So we're going to make sure that we're getting three different caches. Yeah. Okay, so let's just run a default sim for the first one. But one of the caveats with upresing is you need to cache velocity. Okay. It has to be cached. If you want to res a sim, you need to cache velocity. So for the first one, well, cache velocity. Now, when you cache velocity, velocity is probably one of the most resource-hungry channels to cache. It uses up a lot of memory, and it also uses up a hell of a lot of disk space. So be aware of that. And if we look on this memory requirements on the CPU, we're on 200.9 megabytes. So you notice it went up by 30 megabytes. What effect it has on the GPU, I'm not 100% sure, because there doesn't seem to be showing any change. Okay, whether that's a glitch or not, or it just doesn't affect the GPU. You'll also notice that we get some information which is going to tell us how much memory we're going to need to up-res. Now you can only up-res on the CPU, you can't up-res on the GPU. So it's telling me that I'm going to need 200 megabytes to run my simulation on the CPU. When I choose to up-res it with the up-resing settings I've got, and I'll show you them later, I will need 1.6 gigabytes. So do bear that in mind, and it tells me my frames are going to be 47, my cache frames, 47 megabytes. When I up-res, they're going to go to a whopping 372 megabytes. Okay, so that's just information to bear in mind. Obviously, you don't. If you're going to look at, if you intend to do up-resing, you want your up-res to be within your RAM limits, and of course you want your CPU initially to be within your RAM limits. Okay, so keep an eye on these figures when you're doing things. So we'll cache velocity, and we'll just run the sim on this first container, and this will be our default. And I'll just pause while he's running. Okay, what I've actually done is I've set the project length to 100 frames because we don't particularly want any more than that. Just check that we get a render there. That's fine. Okay, so by default, if we look into up-resing, we're going to up-res scale of 2, which means basically double the resolution. And if we want to achieve that just by normal resolution changes, we can halve the voxel size. Okay, so this is equivalent of up-resing that by 2. We've doubled the detail. And in this case, I want to run this one just as a normal sim, but with higher detail. So I don't need to cache the velocity. I'm not going to need velocity because I'm not going to up-res this one. So we might as well have that off. It saves us quite a bit. We go from 1.5 gigabytes to 1.3 gigabytes. And I'll switch this one off so it's not confusing us, and I'll just run this one. And again, I'll pause while it's doing that. Okay, that took 58 seconds. So I'll switch that off now. I'll put this one back on, and what I'll do is I'll up-res this one. Using the default up-res setting of 2 should give us roughly the same amount of detail. And to do that, I need to switch it from cache to up-res. And what will happen is we will get a new cache that will say up-res. I'll show you that in a minute. And well, let's just run it and see. Again, we were 58 seconds, remember, for this higher res one. Let's see how long it takes to do the up-res. And again, I'll pause. Sorry, just as a matter of interest, this initial simulation we've done, we had to cache velocity because we will need the velocity for the up-res. If we're not planning to move any particles around in the new one, and we're not going to need to do anything that requires velocity, we don't need to cache velocity again for the up-res. Unless we were going to up-res the next up-res, if you see what I mean, in which case you would need to cache velocity. So if we were going to up-res to 2 and then we wanted to up-res that again to 2, in other words quadrupling it, we would need to cache velocity. But in general, you don't normally want to up-res your up-res, so why bother caching velocity again? It's using up memory, we don't need it. So we can switch off cache velocity and hit up-res. And as you see, we get a new folder here. Let's just, I'm not really sure why it's giving us that. That could be because we've got the other containers active. So let's just switch that container off, okay? And go back to this one. Remember, if you're going to stop an up-res, you want to go back to the original cache, not the up-res cache. So in fact, we can delete that. And do an up-res here. Again, we don't need to cache velocity. Let's see if we lose that bounding box issue. No, for some reason that's still coming through. Whether that's a glitch, a bug in the version I'm using, I don't know. Let's switch off these emitters, see if that does anything. Let's see what we get now. We don't want to up-res that. That was the error because I didn't cache velocity on that. Remember, if you're going to start again, you need to go back to the original. Okay, yeah, that's better. Why it was seeing those emitters there, although they're outside of the sim, I don't know. There might just be an issue with the version I'm using. So let's just pause here. While that's doing its thing, again, it's worth noting, it's going to be a lot slower because we cannot use the GPU for up-resing. So we'll automatically switch over to the CPU. So do bear that in mind. You are going to get a performance hit if you've been happily relying on your GPU in the past. You may say then, well, why bother? Why not just do a higher res? And that is exactly what I intend to show you now. So we went from 58 to about a minute to 2.2 minutes 26 seconds. So because obviously we're using the CPU as opposed to GPU. Now if we want to now start comparing these, we can put these back on. Now this one I want to be representing the original, okay? Let's have that one representing the up-res. So we can pick and choose whichever one we want, okay? That one using the up-res, and we'll have this one using the high resolution. Okay, and if we now just render a frame, and I'll pause while it renders. Okay, so let's just type recording. Yeah. So we finished. The thing we really want to be looking at is this. Oh, he says having switched the render off. Sorry, let me render to the actual picture view. Okay, so we're not going to lose this now. So here's our original low res sim. This is the up res of that same sim, and this is the one with a higher resolution, which is going to be identical in resolution to this. This up res was a double that resolution, and this is actually double that resolution, half the voxel size. The main thing to notice is this. If we look at the gross overall shape of this original sim, and if we take this area here, okay, have a look at that area, and now have a look at the up-res. The up-res keeps the overall shape identical. What it does is it adds a detail within the existing data, so it's adding detail to stuff that's already there, okay, without affecting the velocity, the movement, the general look of the sim. In this situation, we get a completely different sim because we've added more detail. There's more voxels, finer voxels, smaller voxels for the simulation to take into consideration. So that where we have like a large movement here we've got so much more information we can get in that the actual density and the velocities are moving stuff around more. Therefore, we get a change in the whole movement of the simulation. Okay, imagine if you've got a very thick syrup pouring out of a cup, and then imagine getting at that syrup a lot thinner with a lot more detail. You're going to get more movement. There'll be a lot more interaction within the simulation. But in this case, where we've up-resed it, all that speed, all that data about movement, temperature, etc., is identical. It's staying the same. All we're doing is adding finer detail into what we've already got. In Max's fume effects, that's called wavelet turbulence. Here we call it upresing. The reason why you may want to do this, although it takes a lot longer because you can only use the CPU, here we were able to use the GPU, is that if you've done this and your tech director or you decide, hey, we like the shape of this simulation, we like the shape of this smoke, we don't want to change the overall picture. What we want to do is add detail in. We can do it by upresing. We could also do it in render settings, and I'll talk about that later, where you can actually add detail into a pre-existing sim in a similar way, and you do it via the render settings. But for simulation scenarios, you would do it by upresing. Okay, so we've got an identical shape, just with more detail. Here we've lost it. If we happen to like that shape, we've lost it there. We've got a completely different shape, okay? The detail is roughly looking the same level of detail, but it's a different shape, okay? So that's basically all there is to be said about upresing. You would use upresing if you wanted to keep your overall shape. But if you wanted more detail and weren't too bothered about the shape, you would go this route. Well, one of the things about high resolution sims is that they do tend to contract in. If this was going to be an explosion, and we were saying, no, the explosion gets to such and such a size. If I then went to a higher res sim, not an up-res, but actually simming with a higher resolution, things tend to contract in more. They get tighter because there's more detail going on, there's more interaction. So if you think you're getting near the edge of your boundaries on the low res sim, you're pretty much safe to assume that when you go high res, you are not going to exceed the boundaries. In fact, you're going to actually contract in less. Okay, so that's one useful thing to keep in mind. If I'm doing an explosion on a low-res sim, and I think, oh, just getting near the edge of the boundaries here, I know that if I'm going to up-res it, it's actually going to be smaller. It'll take less space. Okay, but as again, when you actually do an up-res, you're going to be using an identical amount of space. If you look here, this is identical. The only difference is there's more detail here, and again you can see that here. Okay. Okay, I think that's really all I need to say about upresing. There's not really much more to it apart from, sorry, these settings. Now this might be slightly different if you're using the demo version, because I'm using a beta version. and things are slightly changed, but the overall principles are the same. Let's just bring up the help, so you can have a quick look at that. Help, and I think it's in container parameters, simulation, upresing. Okay, have a read of these. It's best if you read it yourselves. Really, it's just the concept of how much detail you want to put in, and whether you want it to be pushing towards the small turbulence or the large turbulence. And as I do have a read of this, it's a very good help system. It's all pretty clear. There's not really much I can add here. Do note this point. You can change the maximum steps for the upres process as well as channel parameters. Okay, so in other words, what that is saying is when we upres it, we upres with we originally simmed with one substep, one iteration limit, and we had various settings set. Okay, when you do the upres, you can change these. Okay, you could probably even change the speed of the movement. So bear in mind, I don't know why you want to change that, but you can change them when you're doing an upres. But in general, the main point of doing upres is to get more detail. Okay, let's see how we're doing on time on this one. I've only done 16, so we'll move on to the other section, and that is timing. Okay, which is pretty straightforward. So I'll clear out these. Let's just switch these all off, and we'll go back to this container. Whoops, not that one, this container, and we'll clear out our caches. We don't need any of these caches now. I'll just pause while I clean things up. Okay, what we're going to do is have, I've got the light smack down in the middle. We're going to have two containers here, so I'll give that a cache 1 and that cache 2. And we'll just check that we've got voxel size of 1. Well, let's give that a voxel size of 1 as well. So we've got identical sims. Let's just switch that one off, and let's just run this one with the default as we did before, and the default timing. Okay. So I'll just sim this one out quickly. Shouldn't take too long. Sorry, I had it left on upres, so I need to switch that back to cache. And now I'll just sim this one out. In fact, let's hide these from the renders. We don't really need to see them in the renders. Okay, so this one is set to go onto cache 2, and what we'll do here. Let's tidy this up a bit. We'll just look at the timescale. We'll put that as a timescale of 50 and sim this one out. Did I have it on? No. Excuse me, I forgot. I'd switched these emitters off before, hadn't I? So let's just put that emitter back on. And I think you can see what's happening here. I'll just do a render as well. Okay, I don't think we need to run it too much more. Let's just have a quick look. Basically what we've done is we've halved the time scale. It's going to go half as fast or twice as slow. Well, that's basically all it does. And that is animatable. Particularly useful for explosions. If you wanted your initial couple of seconds of the frame of the sim, or a couple of frames of the sim, a few early stages, you can have that set up to about 200%, even more, and then ramp it down very quickly to say 25%. That way you get a very fast blast slowing down. We'll talk about velocity in a minute. With damp velocity you can also use that to slow things down, but that is quite a good useful way of doing things with explosions. Very fast initial burst, and then slow it all down. Another useful thing you can do, if we switch these off and we just look at this container, is do some freeze framing. So let's just move that over here. let's see how. Okay, we'll go up to say about frame 45, and we'll animate from 45 to 46, going from 100 to 0. And what I'll do, just for the fun of it, let's stick a target camera on, and I'll this is the point we're freezing at 46, so let's get the camera keyframe there, and then let's move it, say, there. So we should be stable there, and then we start moving. Okay, and now I'll sim that, and I think you know what's going to happen. At frame 45, the timescale shoots down to 0, so it'll basically freeze. And let's just, well, in fact, just for fun, let's do a sim, render while sim. Simulate while rendering. That way we can do a. And as you see here, we discussed that earlier. In fact, it's going so fast you can barely, every now and again you'll see simulating. So it's not necessarily going to save us much time because we've still got a sim and then we've got a render. This just means that we can see it all in one go. Remember, it's at 45 we get the freeze, or we should get the freeze. And it's going to be an abrupt freeze. We could slow it down gradually to a freeze, but in this case I've done an instant freeze from frame 45 to frame 46. So I think they call it this the matrix bullet time effect. Okay, 46, 47, now it should have frozen. There shouldn't be any movement actually in the sim itself. The movement will be just what it appears to be moving. It's because the camera's moving, and I'll just pause and let that render and you'll see. Okay, it's finished rendering. 3 minutes, 4 minutes, and there you see we've frozen it, and I did the camera track round. Pretty straightforward. Okay, now on that note, I'm going to delete this track and rerun the sim as it would do normally. And there's a question that's commonly asked, so it's slightly jumping the gun. It's in rendering. It's a concept of, in this initial case, what I just showed you was that we could do a bullet time effect. We can freeze the simulation for a specific, or even slow it down and freeze it for a specific number of frames. But what if you want, let's say we've created a simulation such as this. Say for example it's a nebula, a space nebula, something galactical, and we like the look of it, but we want it frozen for the whole duration of the render for every frame. How we go about doing that? We go about doing that with something called frame offset, and I'll just show you how we do it, and then perhaps that will explain it slightly more when you see what it's actually doing. So let's say, for example, we like the look of it here at frame 43, and we want to hold that. The simple way to do this is to set that to -43 and our frame step to 0. Frame step, it means it's going 1, 2, 3, 4. By default it's on 1. You could have it on 5. You could render every 5th frame. But to get a freeze frame effect, you choose the frame that you like, that you want, and you put a negative on it, -43. Put your frame step to 0, and now we've frozen 43. And just to show you, to prove it, I'll render it. While that's rendering, I'll also just cover something else. The concept of frame offset. If you had, let's say we had a whole set of oil fires going on, and we've got multiple containers, what we can do is we can just simulate one, and then we can use the data from one simulation over multiple containers which are spread around our scene. Imagine oil rig fires going off into the distance, and we can use the frame offset for each one. We can set one on 0, next one on 10, next one on 20, 40, what have you, and we're going to get different, we're going to get the same simulations for each container, but they'll be kicking off at different times. So they'll look different. They'll look like they're different fires, although they're all actually the same fire, just starting off at different times. So that's one another reason why you'd want to use frame offset. And I'll show you some examples of that in future tutorials in this series. But let's just let this one finish so we can prove our point. Okay, so here we go, frozen. And it's not frozen because we've freezed the sim timing. What we've done is we've taken a particular frame 43, and told it to use that for the whole of the render animation. While I was here, I did another render. Look at the render times: 4 minutes 2. I did one at 1 minute 50. And let's have a look at any frame, because they're identical frames. Let's have that one that's set as A, and that one set as B. And can you see any noticeable difference in quality? No, none at all. And we've quartered the render time. And how did I do that? Well, let's have that off. It's quite simple. In the render settings, under the density graph, this initial point here is normally 0.0000. Okay, it's at the origin. If I just slightly move it over to the right, 0.001, you don't see any difference in the rendering, but you get a massive difference in the render times. Picture here. From a quarter as far, well, not a quarter, half as fast, or twice as fast, sorry, half as fast, twice as fast, okay. And as I said, you really can't see the difference. This is the quick one. And this was the original one. So there's a handy little speed tip. In fact, I should tell you who I got it off. I got it off the net, and I can't for the life of me remember where I got it. It's off a YouTube vid. I think it's a fellow Brit. No, I might be wrong. I think it's an Oz or a Kiwi. If I can remember the chap's name, I will pass it out and give him credit where credit's due. So that's not something I discovered. That's something I just that I found out checking on the net. I think the guy's name is Brian. Let me just pause and see if I can find. So I want to give credit where credit's due. I can't find the actual tutorial, but I'm pretty sure it was Ben Watts. Ben, if you're listening to this, hi, thanks. I'm pretty sure it was Ben Watts that gave me that tip. Okay, so just by putting that at 0.001, you save a lot of render times. Okay, let's just quickly go over the other sections here. They're pretty much self-explanatory, so what I will do, I don't think I've got it open. Let's just quickly look at the help. And container parameters, simulation, timing. Okay. Frame range, I think that's pretty self-explanatory. If we've got a lot of animation going on, let's say it's 1,000 frame animation, but we're only going to have our explosion on frames 100 to 200, that's where we'd set that. So we don't really want to be simulating for the whole animation. We only want a simulation for a specific period in time. I think that's pretty straightforward. Yep. Start clean simulation is what's on by default. Whenever I do a sim, it clears everything restarts the simulation from scratch. Okay. The other alternative is to load a simulation state from file. Let me just show you the caches that we had. Okay, here's some caches. Whether it was the last one or not, I'm not really sure. But we get the autosave file, which is our file automatically saves as soon as we hit simulation. These are our actual BCF cache files for each frame. But we also get two things. We get a simulation timing and a last sim state. Not 100% sure what that is. Do a search for it. But this is your last sim state. And I believe, which is fine. If we just have a quick read of this, it's best really for you to read it. There's not really much more I can say here that isn't actually already written there, and I'll probably make it more confusing. Blah blah blah, blah blah blah, blah blah blah. Okay, I think you can all read that and understand that. I can't really say it any clearer than that. Basically, the idea being that you want to pre-roll a sim. Let's say we wanted a nice gaseous fire burning. Let's go back to an example of oil wells on fire. When we come on into the scene, we don't really want to see the oil wells starting to catch fire. We want them already on fire. So we can sim up to say this point, and then we can go back and load the simulation from uncheck that and load our simulation state from a particular BCF file, and either continue from that file or do whatever you want. So it's basically the concept of pre-rolling. I suggest that you read the help on that and play around with it. I don't tend to use it that often, so I'd only be confusing the issue for you. But I think it's fairly well explained there. Sorry, just switched that on. Fairly well explained there, and ask Jasper and ask on the forums if you've got any issues that you need clearing up on this. As I say, it's something I haven't really been using lately, so I'm really not 100% familiar with it. So that pretty much covers that. I'm going to get into velocity in the next tutorial, simply because we're going to be wanting to look at particle velocity scale, which will take up a bit more time because we'll be obviously dealing with particles. So although there's not a lot here, it's something I want to save for a separate tutorial. So that's basically upresing and timing. There's not a lot more I can say about them. Okay, have fun, and I'll see you in the next section.